Hello everyone. In the previous video, we had spoken about this force of interest, and that time whatever we spoke about, it is considered to be a constant number, the delta force of interest. What will happen if it is a function of time period t? That is what we are going to see in this particular video. Okay, so first of all, let a t be the accumulated value of an investment at time t. Then let a p plus, let me take a smaller value, 1 by p equal to accumulated value of that investment at time t plus p. Then we have the accumulated value during the period, during the period 1 by p will be the difference between these two, means accumulated value at time t plus 1 by p minus accumulated value at time t. So that means the interest for that period, for that period 1 by p will be whatever is the accumulated value during that period 1 by p divided by the original accumulated value at time t, means will be a t plus 1 by p minus a of t divided by whatever the initial accumulated value at time t. Now, the nominal annual interest rate compounded P3. Either I can write like this or I can write P3 will be, means P is the conversion, number of conversions will be that we write it as IP is equal to, so this is for this period 1 by P. So if I want to calculate it for P3 period, then I need to multiply P times this. So it will become P times A T plus 1 by P minus the interest, whatever is there. Now I can say where P is the number of conversions during the year. Okay. Now, the question is, if this P happens very frequently, means if P is a very large number, or I can say limit P tends to infinity of IP will be limit P tends to infinity P times A of T plus 1 by P is this by A T. Now let us assume, let H equal to 1 by p. Then if p tends to infinity, then h will tend to 0. So I can rewrite this as limit p tends to infinity, I of p is equal to limit. Now I will convert this. I'll bring this h instead of p. That means here instead of p tends to infinity, it will become h tends to 0. And this will become, when h is 1 by p, then p will be 1 by h. A of t plus h minus a of t divided by a of t. Now this a of t does not involve h. I can take it outside, but I need to keep the h inside the limit only. So let me go to the next page. So we have now limit p tends to infinity, I of p. That I can write it as I of infinity is equal to 1 by a of t times limit h tends to 0, a of t plus h minus a of t divided by a of t. In calculus, the definition of the first derivative of f of x, which is f dash of x, is given by, I'm writing the definition in terms of limits. F dash of x equal to limit h tends to 0, f of x plus h minus f of x divided by, here I wrote it, I should have written h here, instead I wrote it wrongly. This is actually h. At, I took it outside the limit, h should be inside. Divided by h. So based on this, based on whatever I wrote within this red box, I can write this I infinity as this whole thing. If I compare this with this is nothing but a dash of t or a prime of t, first derivative of a of t. By this a of t. So this I of infinity is nothing but nominal annual interest rate continuously compounded or it also can be written as instantaneous rate of growth of investment per rupee invested at time t, or it's also be called as force of interest at time t. That is what is about I infinity. This I infinity is also called as delta of t. Right? So that is about delta as a function of t. In case if you find the contents of this video to be useful to you, I request you to please like it, share it with your friends, and also subscribe to my channel. Thank you.